I want to do a quick example of another Mohr circle problem. So we're going to look at this stress state, and we are going to calculate the principal stress state in 3D, the principal stress state in each plane, and look at some arbitrary rotations that I might ask on a problem set. So let's go ahead and identify our planes once again. So I'm going to do, this is going to be my 1, 2 plane. This is going to be my green. Let me go here in my 2, 3 plane, and then I'm going to go here for my here, here, here. That's going to be my 1, 3 plane. So again, depending on the analysis we're going to do, actually I'm going to solve it first the way I like to do, which is with Mathematica. So if I want to find, let's see, the principal stress state in the, let's say, the 1, 2 plane first. So I'm going to find out, I want basically stress 1, 1. Let's make sure that I'm stress 1, 1. So I want that. I want stress, 2, 2. And then I want stress 1, 2, or 2, 1. So this is going to be my, again, sigma xx, sigma yy, and then my strain. So I'm going to do this as my, I'm going to call this my 1, 2, my 2, 3 is going to be equal to this, except I'm going to just change here. So I'm going to do 2, 2, I'm going to do 3, 3, then I'm going to do 2, 3. And then finally, for my 1, 3, I'm going to do the same thing here, or actually, let's do this right here. Set it equal 1, 1, I'm going to do 3, 3, and then I'm going to do 1, 3. There we go. So if I want to find out, if I want to solve for my principal stress state here, I am in my principal stress state because my shear stress is 0. Same thing here. And we can figure out and draw those again. This would be my sigma 1, this would be my sigma 2, again, because a negative value. And then we'll look at this in the Mohr circle approach. But here, the way I'm going to solve it, same way that we did previously. So I'm going to look at 1, 3, 3. When does that, when I multiply t dot that, when does this equal 0 and solve for theta? Oops. So let's do, actually, I want to do t dot 1, 3, then I want to take away the third component. I never make mistakes coding, right? And I want to look at this numerically here. And so I could look in, calculate some of these values. So I could look at here, times 1. Actually, let's go look at this expression right here. So I could do that. So that's 1 angle here, theta, or actually degrees, or minus 30 degrees. So let's go ahead and back, and let's actually solve this from the, again, using the Mohr circle. But if I wanted the 3D, again, 3D principal stress state, I just get my eigenvalues, and I find my stress, and let's confirm this. So let's look at that numerically here. Oops, question mark. And it should be this, this, and this. So again, and I could do any, you know, if I want to rotate my 1, 2, I'll do t dot 1, 2. If I rotate it by, we know that here, if I'm rotating in theta slash dot, if this is my principal stress rate, I know a theta rotation of 45 degrees will get me into my maximum shear. So this should be a value of 31. Let's see if that makes sense. Yep, minus 31, minus 31, perfect. So we can confirm, again, that should kind of make sense. Again, at the center of our circle should be minus 31. And again, that radius is 60, or that diameter 62. So now I need basically this, my radius of my circle, 31. So let's go ahead and approach it. And I can do any arbitrary rotation, minus 15, I can do 37, et cetera, et cetera, et cetera. That's a nice linear algebra approach where you don't have to do any more kind of trig. But let's go ahead and approach it, and let's see if we can get the same answers from the our Mohr circle approach. So I want to do my easy ones first. So let's go ahead and do blue, tau, my sigma. So my sigma is going to be this minus 62. Again, megapascals, 0. So my circle's like this. Again, it should hit here. My center is going to be at minus 31. So my sigma 1 is not minus 62 because 0 is greater than that. So 0, my sigma 2 is going to be minus 62. And I'm already in my principal stress state. If I want to find my maximum shear, I'm going to rotate either here or here. I probably want to rotate here because it's positive, but 45 degrees, and I'll get that value right there. So that's my sigma 1, sigma 2 for that plane. Now for my green, same thing right here. Should give myself some extra room for the nastier one. But here, I'm going to have a value of 34, 0. Right here, center at 17. So that radius, if we plug in there, it should be 17. Right here, this should be 31. Sorry for the notation. But here, my sigma 1 is equal to 34, and my sigma 2 is equal to 0. Now we should go back and calculate in just a second. You can kind of see, if you plugged in here for 45, you should see, my stress state at a rotation of 45 degrees. My stress state should be this. It should be 17, 17, and it should be 17. All right, now let's go ahead and you can confirm that Mathematica. So now let's look at this one. It's a little bit tougher. I should have given myself much more room. So tau, and then this is my sigma. So I have values at minus 62, at 34, and then 89, minus 89. So I have points here, 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 and here. And I go around here, and I could look at kind of this here. So if I draw my point, I don't know if it's going to be actually the 0 is going to be my center. So I have a point here, I have a point here. I need to rotate clockwise sub 2 theta. I know that this distance here is 89. So I can solve now. So if I want to figure out this is going to be my radius, I know that that distance is 89. So I could solve that sine of 2 theta is going to be equal to opposite 89 over my radius here. So I could solve for that. I could also similarly solve for my cosine of 2 theta is going to be equal to some x value over r. So let's go ahead and solve that math by hand. So sine of 2 theta. And get into solving this, these geometric relationships that we saw just right here. And let's go ahead and solve them and figure out what's our radius. So same procedure as last time. So I'm going to have some data, and that's going to be equal to, let's go ahead and look back at our data points right here. So we have minus 62 and minus 89. So 62 minus 89. Then we have 34 and 89. 34 and 89. Let's go ahead and solve that. Let's do the fit my data, linear function of x right there. So I could solve now for my center. So solve when this equals 0. This equals 0 for x. So my center is equal to minus 14. So, and again, we could kind of double check that with, it should be sig xx. So minus 62, basically plus 32 divided by 2. Actually, here we go here. Actually 34. That makes more sense. So minus 28 divided by 2. Again, that's from just your Mohr circle expression as well from our lecture notes. So here we should be able to confirm that sigma xx plus sigma yy divided by 2, that's my center. So let's go ahead and go back to Mathematica. Now we've confirmed that. Again, multiple ways to confirm your answer in these kind of problem sets. So if my center is minus 14, and I could also do my radius by knowing that my Euclidean distance between 2 points, data 1 and data, actually, let's see if we can do data 1, data 2, and then do this divided by 2, because that's our here value right here, numerically. And so this is our radius. So our radius equals this. So we know that if that's my center, so my if that is the center there, and we know that my radius is that, so my sig1 will be center plus the radius, and then the center minus the radius right there will be just like this. So actually not -4, minus r. Principal stress states, and actually we could solve for our theta value as well. So now I can know that sine, actually let's go ahead and write these values down first on our, so 87 minus 115 approximately. So here my sigma 1 is going to be around 87, and then my sigma 2 is going to be minus 115. And then now I could solve, again, my radius, sine of 2 theta. So right here, solve sine of 2 times theta. And I could do it in degree mode. Set equal to here, where now I'm going to have my 89 divided by my radius. So solve for theta. Get that value, 30.84. So let's go ahead and look back there. And again, so look at here, this is the value of minus. And if we look back at this expression here, if I look here, I need to rotate, again, clockwise, right? So that would be at minus 30. So our linear algebra approach and this approach yielded the same answer. Fantastic. So we're good to go. So now we can look and figure out what is our principal stress state. So now, actually, I could go ahead and plug in. If I plugged in this value of minus 30, I could also double check and make sure this is our principal stress state. So if I did, for example, my 13 t dot 13 slash dot theta goes to this, I'm going to get this expression. Again, 0 here, effectively 87, again, same value, just like we got for our Mohr circle. So let's go ahead and go back over here. And now let's try to draw our full 3D Mohr circle state. So what is our sigma 1? So what is the largest sigma 1 value? So 34, we have 87, and then where's my other one? 0. Okay, so sigma 1 is going to be this 87 point something something. Sigma 2 is going to be the largest of my sigma 2's. So that doesn't work, so that's 0. Then my smallest sigma 2 is going to be this. So minus 115, and then let's go ahead and double check our answer. So what is our principal stress state from our linear algebra approach? Well, it's our eigenvalues, minus 115, 87. That's it. We're good to go. So now I can go ahead and draw my 3D Mohr circle state. So I'm going to just do right here, my tau, sigma. So my sigma is going to be, there's a point at 0, minus 115, then the 87. So I'm going to draw here, here, here. And my largest shear stress is just going to be this 87 plus 115 divided by 2. That'll give me kind of this radius. That's it. You can see we get the same approach from either Mohr circle or linear algebra approach, and it's just whichever is most comfortable. And you can honestly, I use both in conjunction. So I use both kind of formats and steps in order to kind of solve some of these problems. So I hope that helps. And then again, we'll do some more problems in practice a little bit later on in some other videos and in your problem set. So again, you can do either of these approaches is going to work. You'll yield the same results, and do it both ways and double check. That's my best piece of advice. Thanks, and I'll see you in the next video. Bye.